Chapter 3, Section 6 is about lines in the coordinate plane. So we're going to travel back to algebra land again. And by the end of this lesson, you should remember how to graph lines, how to write equations of lines in slope-intercept form, how to write equations of lines in point-slope form, and be able to classify lines as parallel, intersecting, or coinciding. So refresh your memory a little bit. Slope-intercept form is the one that you're most familiar with, the second one on here. That's y equals mx plus b. The m is really important because that tells you your slope, and the b is also really important because that tells you your y-intercept. The point-slope form one we tend to use when you're given a point and you're given a slope, and we plug it into this equation. Now this equation is really messy, so we tend to simplify it and get slope-intercept form. But then the other two that people always forget is the equation of a vertical line and the equation of a horizontal line. So remember, your horizontal lines go this way. They have a slope of 0. Vertical lines go like this, and the slope is undefined. So if you can remember Hoy Vux, you can remember that vertical lines have an undefined slope, and their equation is x equals a number. Hoy is horizontal lines have a slope of 0, and it's always y equals a number. So if I tell you something like x equals 4, and you're supposed to graph that, you go on the x-axis, you find 4, and you make a line. So let's prove something. If I tell you that the slope is this formula right here, we need to somehow prove that that equals this right here. Now it looks very similar. So let's make our two-column proof. We have our statements and our reasons. So the very first statement we can write is that m equals y2 minus y1 divided by x2 minus x1, and that is given. And then remember what we're trying to get. We're trying to make it look like this. So the first thing we're going to do is we're going to plug in or replace the x2, y2 with xy. And we can do that because of substitution. Remember, in every formula, we end up with just a solid x and a solid y that don't change. So that means this becomes m equals y minus y1 divided by x minus x1. And now, what we have to do is multiply both sides by the x minus x1. The reason we can do this is the multiplication property of equality. So we end up with m times x minus x1 equals y minus y1, which is this formula. So this formula, this point-slope form, comes from the slope of a line. So now let's use those. Write an equation of a line with the given information. A line with a slope of 3 through the point 2, 1 in point-slope form. So they give us a point and a slope. So we're going to use point-slope form. Y minus y1 equals m times x minus x1. And then plug stuff in. This is your m. This is your x1, y1. So we end up with y minus the y in my point, which is 1, equals my slope, which is 3, times x minus the x in my point, which is 2. And because it told us to write it in point-slope form, we get to leave it like this. If they told us to write it in slope-intercept form, which is y equals mx plus b, we'd have to convert it, like the next one. So this next one's a lot of work, because it just tells us the line through these 2 points, and we need to put it in slope-intercept form. So if we take a look at our 2 points right here, the first one is over 0 up 4, and the next one is over 1 up 2. Now we need to know 2 things in order to put this into slope-intercept form. We need to know the slope, and we need to know the intercept. awesome for us, this right here is the y-intercept. So this is our b. So the only other thing we need to find is the slope. And we already have tons of practice doing that, so let's plug it in the formula. Here's second y value minus our first y value, divided by our second x value minus our first x value. So we get negative 2 on the top, not negative 4, divided by a negative 1, so our slope is just 2. And because we know our y-intercept is 4, it makes it really easy to plug into y equals mx plus b. So y equals my slope, which I just found was 2, x plus my y-intercept, which is 4. And that's it. I want you guys to pause the video and try this one on your own. A line with an x-intercept of 2 and a y-intercept of 3. So hopefully you remembered that if something crosses the x-axis at 2, that we have the point 20. If something crosses the y-axis at 3, we have the point 03. And then it's awesome because this is our b value in y equals mx plus b. And then all I did was find the slope and then plugged it in. So now let's get to the good stuff. Let's actually graph some lines. Remember, in your y equals mx plus b, this is your starting point. And this is where you start on the y-axis, since it's your y-intercept. And then this slope is your rise divided by run. So this first problem here, this is my starting point. I'm going to start down at negative 3. And then my slope, remember you can change every number into a fraction by putting a 1 underneath it. So that means I'm going to go up to right 1. So up to right 1, up to right 1, and you can make as many of these points as you want till either you go off the graph or you get an idea of what the line looks like. And then all we got to do is connect the dots. Now one thing I'm going to remind you of is lines go on forever and ever, so make sure you have the arrows there. And then make sure it takes up your whole graph. Don't draw me little lines like this. They go on forever and ever, so they should at least extend off of your graph. Let's skip 2b for a second. We'll go back to it. Let's jump to 2c. So remember I told you that you need to remember Hoy-Bucks. So this says that y equals negative 4. That means it's a horizontal line. It's going to have a slope of 0. And that means I got to find where y equals negative 4. So because this one that goes up and down is our y-axis, I'm going to go down 1, 2, 3, 4. And then I need a horizontal line with a slope of 0 that goes through that point. And that's it. So now the next one is a little confusing because this is written in point slope form. It's really easy for us to find the slope. It's this guy right here. So remember that tells us that because it's negative we're going to have to go down to right 3. But then remember point slope form has this x1 and y1. I think this is a little easier to see. The x and the y are your point parts. So if we take a look at this equation over here, if I have y minus 3, the 3, not the minus part, just the 3 is my number. This 4, just the 4. It's not the minus 4. So if we come back over here, in my point, where I'm going to start is I want to make this look like x minus something. So it's got to be x minus a negative 2 in order for us to say plus 2. So it's at negative 2, comma, remember it's just the 1. So basically you can think it's whatever the opposite is, because it says y minus 1, it's going to be a positive 1 here. X plus 2, it's going to be a negative 2. So this point is where we're going to start, back to up 1. And then we're going to use our slope. Down to right 3, down to right 3. Just like before, you can make as many as you want. Oops, this should be right 3. Or until you get the line looking like you want it to look. And then draw through it. The other thing you can do for 2b is you can put it into y equals mx plus b form, like this one over here. And if that makes more sense to you, feel free. So if I give you more than one line, you can tell that they are parallel because they are going to have exactly the same slope. We know that. But parallel lines have to have a different y-intercept. If they don't have a different y-intercept, then there's something called coinciding lines. And coinciding means like the exact same line. All of the points line up. So if you have the same slope and the same y-intercept, they're not parallel, they're right on top of each other. And then intersecting lines is when they have different slopes. And they can even have opposite reciprocal slopes like we talked about yesterday. That's a special kind of intersection, but it's still just an intersection. So determine whether the lines are parallel, intersect, or coincide. So we have to look at two things. We got to look at their slopes first. So we'll start off with an easy one. The slope of this guy is 2, and the slope of this guy is 2. So they have the same slope. Two things can happen if they have the same slope. They can either be parallel or they can be coinciding. So the next thing we got to look at is the y-intercept. +3, -1. So because they have a different y-intercept, these two are parallel lines. So the next one, the first part, I give you a nice easy y equals mx plus b. The slope is 3. But this over here, we can't tell what the slope is. So we have to put this into y equals mx plus b form. So if I have 6x minus 2y equals 10, I want to get y by itself. So the first thing I'm going to do is take away the 6x from both sides. -2y equals -6x plus 10. And then divide everything by -2. So now I get y equals +3x minus 5. So let's take a look again at, we have the same slope. It's a slope of 3. So same slope. And then let's look at our y-intercept. I have -5 and -5. So they have the same y-intercept. So because of this, they are not parallel, but they are coinciding lines. Means if I were to graph them, they would be right on top of each other. So we have reached the end. You should be able to graph lines, to write equations in both slope-intercept and point-slope form, and classify our lines as parallel, intersecting, or coinciding. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.